Okay, in this video we're going to show how to simulate using a subroutine Fortran program in Abaqus. Okay, the first model does not contain the additive metal, and we're going to see the second model where additive metal is included. Okay, we start by introducing the general variables and then part creation. You will see that in this example we have a coated metal. Okay, in this example we're going to show how to change the dimension of the coated metal and the base metal. Now, next we're going to select which section and material is used for the base metal and the coated metal. Okay, as you can see, zinc is used as a coated metal, protection metal. Okay, here the properties for both metals are used. Okay, it is temperature dependence, now in the assembly it's very important to note that the reference, the origin point must be in the start of the joint, so make sure that you translate your parts to be the starting point in the origin. Now setting the steps to include the welding time. In this example, the welding time that it takes is 25 seconds. Okay, if you want to have results in each increment, you can decrease the max allowed temperature change per increment to see how the temperature is increasing in each increment. In the cooling process, we're going to change that to 20 degrees Celsius to give more detailed temperature changes. Okay, now I'm going to set some of the radiation variables and the inert gas constants. Now, this is where we include the loads. We must choose the user defined. Okay, let's look at the code. This code is for surface heat flux, and it's based on Kratz model. Okay, so it's simple. You just need to um, modify the voltage, the currents, and also the source heat efficiency, eta, and the speed. This is the model that is based on. Okay, and you must also give the R0, which is the disk reduce for the arc welding. Make sure everything is set as the example. Okay, this is the general ambient temperature. Okay, and after that, it's time to execute the meshing. This is important. Step 2, you want to refine the meshes around the joints. Okay, bear in mind that increasing the element size or decreasing the element size will cause the simulation process to be a little bit longer. After that, we're going to run the, the job sets. Okay, but before doing so, you need to make sure that that certain requirement is met. We're going to talk about that at, at, at the end of the video. Here we choose the, the subroutine to be selected. Okay, and then we are done. We run the simulation. Okay, it's going to compilate the Fortran program, and then we're going to calculate the flux. In this case, is a surface heat flux. After the simulation is complete, okay, it may take a while. Okay, we're going to see how the results are. Okay, you can see that here we can see the welding is moving nicely. You can set the max temperature visualized to be here is like set here. Okay, you can set it in here, same thing, to show the zone where the metal is welding. Okay, we're going to show you now how to extract some informations as requested. The most important is the nodal temperature. We can also extract the residual stresses. Also, if you want the pressure applied. Okay, we're gonna speed things up. The cooling parts. Okay, you can see that the temperature is increasing even if it's in the cooling process. Okay, and then it's going to decrease again. Okay, here you can see where the weld is in that nice zone. Okay, if you want to test how the penetration is, you can either decrease or increase the amperage. Okay, here we're going to create first paths. This path is going to give us the information around this zone. Okay, nice. Okay, now we're going to talk about the requirements. This is the two software that you must install in order to run the DFLUX subroutine. Also, you need to make sure that these two lines are included in this file. Okay, it depends also on which version you have chosen. Okay, the first line is not going to change except the version of the file. Here you must specify the same version of the Visual Studio file